All right, welcome back everybody. This is EOC Practice 1 through 20. It's the Google form EOC Practice 1 through 20. There is a 1 through 20, then there's another 20 problems, then there's another 20 problems, and another 20 problems, all right? Hoping to make a video of all of them, but if I don't get to all of them, then you may end up doing the last 20 or maybe the last 40 on your own. But remember, I have to see your work. You've got to turn that in to get credit for this. You cannot just submit the Google form with answers without giving me some paperwork, all right? That goes for everybody. I gotta see you working on these things, okay? All right, let's get started. Depending on how long we take, I may break this up into two, but these problems, this comes from a different set of problems. The first ones we did, the first few videos that we've done up until now, have all come from the 2019 Tennessee EOC sample test. So they are probably more current and probably much more applicable to what you're going to see in April or May of this year. So these are just more generic problems, but they did come from national EOCs. So we'll talk about them. It is good old Algebra 2. So without further ado, let's dive right in. Number one, which is equivalent to 49 to the 3/2 power. First of all, you have a calculator. If you happen to be on a calculator and you did not, if this popped up on the section without a calculator, then you would rewrite this as 49. You should identify 49 as a perfect square at this point in the year. You're going to separate that 3/2 into 1/2 times 3 because that's the same thing. 3/2 is the same thing as 1/2 times 3. Square root of 49 is 7. 7 to the 3rd power is 343, I think. I'm going to go ahead and do 49 times 7 just to be sure. 63, 6, 28, 343. Answer is D. All right, let's move on. Number two, which expression is another way to write the cube root of 125x to the 4th? So, first of all, a lot of these questions, everyone listen to me, all right? Everyone listen carefully. A lot of these questions, the 5 trick will work. If you see variables in the answers and a variable in the problem, you can plug a 5 in and see which one works, okay? That's the way almost every one of you made 90s and above on the rational expressions, all that greatest common factor stuff, all right? So we can plug a 5 in there, and there, get very quick at solving them, and you would find your answer. But without that, we're just gonna rewrite that thing. First of all, the cube root of 125 is just 5. So I've already pulled that out. I still have an x to the 4th left under there, but I'm going to rewrite it as x to the 3rd times x. Remember that little trick? X to the 3rd times x, there's an invisible 1 here, is the same thing as x to the 4th because you would add those exponents. So we're going to pull the cube root of x to the 3rd out. Sorry, there should be a 3 here, and that would be our final answer. Except that answer's not up here, so I got to see what's up. So we're going to say 5x is on the outside. I'm going to go with one of these two answers. I think we can cross those two off. And then we got to rewrite. I got ahead of myself because I wasn't looking at the answers. I'm going to keep that 4th under there. A 3rd root is the same thing as a 1/3 power. So I'm going to rewrite the cube root as a 1/3 power. It's only applied to the x because the x to the 4th is only the only thing under there. My final answer would be 5x. Uh-oh, I don't have the x out there anymore. 5x to the 4/3 power. So I'm going to go with B on that one. Let's double check that answer just to make sure. Yep, there it is, B. All right. If x and y are real numbers, what is the simplified radical form? This is another very similar problem. We're getting a lot of exponent and radical work. So that 1/5 power, first of all, I'm going to go ahead and distribute this. And remember, power to a power is multiplied. I'm going to see where that gets me. X to the 2/5, y to the 1. All right, so I'm already thinking that 2/5 could be broken up into 5th root of x. Now, I won't go that far yet. Hold on. X squared to the 1/5 power. I'm just splitting up that 2/5 times y. I'm going to turn that 1/5 into a 5th root. That 1/5 is turning into this 5th root right here of x squared. And let's see if that answer is A. Yep, there it is. All right, so we split that up into, we distributed, and then we split that 2/5 up into x squared to the 1/5 power. The 1/5 turned into a 5th root. All right, let's keep moving. Number 4, simplified expression. More radicals and exponents, okay? So we can take I'm looking at the answers, and I'm going to go ahead and I'm just going to go ahead and work out what's under the radical sign first. 36, treat numbers like numbers. Numbers always treat like numbers, okay? Then you apply different rules for exponents and coefficients and things like that. Numbers work with numbers. So 36 divided by 4 is 9. X to the 8th divided by x to the 6th. You subtract exponents when you divide. So there's where we are. Final answer, 3x, A. All right, not bad, not bad. All right, so we got some radical signs, and we're just going to use FOIL. We just have to remember our rules of multiplying radicals. So we're going to do first, we're going to get 2 times the square root of 25, which would just be 5. I'm just going to go ahead and put it right here. Okay, no radical left. Square root of 25 is 5. Outers, inners, last. This is a 10, 2 times 5. Remember, I always do that. I tend to make 5s look like 6s. So that's a 5. Remember, radicals add and subtract a lot like variables. You don't do anything to the radical, you just add or subtract whatever's in front of them. Okay, so minus 2 apples, apples and oranges, right? Minus 2 apples plus 3 apples is plus 1 apple. And my apple in this case happens to be root 5. Minus 3, final answer is root 5 plus 7. So let's double check and make sure that is B. Yep, moving on. Number 6. 6 out of 20, we're almost done. What is the sum? Okay. This isn't as bad as it looks. It looks kind of fancy, like we're going to have to do a bunch of stuff with radicals. No. Square root of 25 is just 5, so we have 1 over 15. Cube root of 27 is just 3, so we're going to have 1 over 3. And it asks for the sum. What is sum? What is sum, Lana? Exactly. Sum means addition, right? Everyone knew that. Okay. So we're going to go addition right there. Excuse me. I'm going to multiply the top and bottom of this by 5 just to get a 15 on the top and bottom. See, my 5 looks like a 6 again. So all I did was write an equivalent fraction with 15 on the bottom, so I end up with 7 over 15. And that's not one of my answers. So, what am I going to do now? Let me double check my work. I'm just going to work it again real quick. Square root of that is 5 times that is 1 over 15. Oh, you know what? I bet it reduced and I didn't even notice that. Plus 1 over 6. Oh, it's a 6 out of 5 here, I think. So that's cube root of that. I didn't multiply correctly. So I got to get this. I'm going to write this one as 2 over 30. I'm going to write this one as 5 over 30. All I'm doing is adding and subtracting. Obviously, this is calculator work if this is on the calculator section, but it may not be, okay? So I end up with 7 over 30, and there's my answer, B. So it's okay to make a mistake. Don't give up. Don't give up. Rework it. Rewrite. If you've written a bunch of stuff, you can spot check your own work. And if you haven't written a bunch of stuff, write a bunch of stuff, all right? I try to tell so many of you that writing is the way to not overtax your brain. Writing stuff down is a placeholder. It keeps it on the paper so you don't have to remember it while you're trying to do other things with your brain, all right? All right, so moving on. Number 7. Oh, I had a little bit of trouble with this one. Obviously, if it's a calculator, then you got your calculator, no problem. So what I did was I actually just plugged that in the calculator. I got some weird decimal, and I set it equal to, now, area of a square. Draw your square. area is all this in here, but it's basically side times side. It's the same thing as length times width for a rectangle. It just happens to be a rectangle where all sides are equal. So side times side works the same as length times width. So side squared equals 2 root 2 plus 3. And you can take the square root of both sides and just decide which one of these is the same thing as the square root of that mess right there. Don't try to do anything fancy. Just plug that in underneath a square root sign, and that's one way to solve it. There are fancier ways to solve it. Literally just do that and see which one of these is the answer. It ends up being B, I believe. There is a better way to solve this. There's a more geometric way of solving it. But it was escaping me, so I'm going to say that's calculated work right there. All right. Number 8. All right. Yeah, I'm definitely going to split this up into 2 videos because we're over 10 minutes now. Which expression represents the quotient? All right. So remember, a polynomial divided by a monomial. You just write each. Monomial on top over the monomial on the bottom, plus, and then the other, basically I just split the top, but you got to keep the denominator under each one. All I'm doing is sort of distributing division, if you want to think of it that way, all right? So I end up getting 2x to the 4th, z to the 3rd, because we subtract exponents when we are dividing their bases, plus 1x squared z. That should be my final answer, and it is right here. So let's double check that that one's A, because algebra teachers do not know everything. We make mistakes too. All right, which expression represents the quotient? We're dividing, so dividing fractions means you multiply by the reciprocal. So I'm just going to rewrite it as the first fraction times the reciprocal of the second fraction. A lot of canceling. We could either multiply straight across and just get a big monomial over a monomial and cancel, or we can do some cross canceling. You can do it either way, all right? So I'm going to say that that 4 is gone completely, and it creates a 3 with this one because I divided them both by 4. The 8 cancels with the 8. The x squared, this is going to be x times x. That's the same thing as x squared, so I'm going to cancel that x squared with both of these x's. I know that's a little weird. I canceled top and bottom and cross canceled at the same time, but there's multiple ways to do it, all right? So don't freak out if you don't quite follow one particular step. And then I'm going to go ahead and multiply across because I'm getting confused as to what's left. I have x to the 6th, y to the 4th on top. I have 3. Don't forget that 3 right there. Y to the 4th on bottom. Look, the y to the 4th cancel. I end up with x to the 6th over 3. Should be C. Let's check our work. C, there it is, all right? And number 10, the last one for this set. Again, this is EOC Practice 1 through 20, and I'm doing 1 through 10 on this section. So which expression represents the quotient? Okay, this is, well, we can do it one of 2 ways. We can factor that really quickly. That would be y plus 4, y minus 8. So if I divided that by y minus 4, the y minus 4s would cancel, and my answer ends up being y minus 8. Or if you don't see that, which you may not see that you could write it like this basically. Factor the top, cancel. Maybe you don't see that. Maybe you just see division, which would be synthetic division. So here's an alternate way to do it. 1, negative 4, negative 8, 32, positive 32, 0. Answer ends up being x minus 8. All right? Either way, we end up with the same answer. All right, and that'll do it for this video. I will start 11 through 20 here in just a minute, okay?